You have fallen into Event Horizon with John Michael Godier. In today's episode, John is joined by Fraser Cain, creator and publisher of Universe Today, one of the world's largest portals of space and astronomy news, with over 140,000 subscribers. In 2006, Fraser joined with Dr. Pamela Gay to create Astronomy Cast, which is among the top-rated and most popular podcasts in the natural sciences. Remember to subscribe to Event Horizon so you never miss an episode.
Fraser Cain, welcome back to the program.
Hey, good to be here.
Fraser, now many things have happened this year, from Artemis to James Webb, and now we have all these space topics to talk about, but what I really want to ask you about are Lagrange points.
Sure. Yeah, I can't wait.
Yeah, I bet you can't.
Hit me with all your Lagrange point questions.
Yes, the many questions. Now, Fraser, what we were just talking off air, this looks like this was a better year for NASA than it's had since the 60s and 70s. So, I mean, this was amazing. What was your reaction to the Artemis launch? Now, I was jumping up and down, but what was your reaction to the launch of the greatest rocket since Saturn V?
It was a clincher the whole way, and I could never get excited about it because I was so nervous about it, and there's no really clear cutoff point. Like when you think back to some of the moon landings, obviously when the people actually set foot on the moon, and you hear that Neil Armstrong has taken one small step for man, one giant leap for mankind, that is a moment that you can celebrate. But what is the moment that you celebrate the Artemis mission? The rocket has ignited. Okay, good. It's cleared the tower. Okay, great. Everything's looking good so far. It's reached max Q. It's detached its solid rocket boosters. Okay, great. Nothing's exploded, and now it's in space. And at no point, I think, was I freaking out because I was so nervous about this thing taking off. And I still am. It's weird. It's this long, slow celebration for something that is still another week and a half in completion as we're recording this episode.
But what we can say is that the launch system itself works.
Oh, yeah.
And we have a spectacular rocket. Actually, it actually outdoes Saturn V slightly, doesn't it? As far as raw power.
Oh, I don't know if it outdoes Saturn V in this configuration. This is the Block 1A version, while the Block 1B version is going to be more powerful and will definitely become the most powerful rocket ever made. The funny thing is that actually the space shuttle was more powerful than this rocket is. But the space shuttle had to carry the orbiter into space, and so it had to replace what would be propellant or cargo with the space shuttle, and so in fact this rocket is less powerful and yet capable of missions that the space shuttle could never do.
That's something, is that the shuttle was my launch system growing up. That was Saturn was done, and the shuttle was what we had. And as much as I love it, it was sort of a folly in a way, because it just didn't. I mean, we're back to capsules now, and there's a reason, ultimately.
Yeah. If you go back and look through the history documents and see what the plan was for the space shuttle, it was going to be way cooler. What it originally was supposed to be is that what is the main fuel tank, the big orange fuel tank, that was supposed to be an aircraft. And then you would put the orbiter on top of the main fuel tank, and then it may or may not have those solid rocket boosters. And then the whole thing would take off vertically. Then the orbiter, the main fuel tank, would carry it essentially to orbital velocity, and then they would detach, and then the first stage would fly back and land like an airplane on a landing pad or on a runway, and then the orbiter would go to space, do its mission, and then it would also enter the atmosphere, and then it would land on a runway. And at some point, because of shifting requirements and challenge is they shifted away from that plan from a fully reusable two-stage rocket towards parts of it being reusable, but really a mostly disposed of space shuttle that we knew today. But I've been going on this rant that every cool idea in spaceflight is sitting in some technical document written in the 1960s by NASA. Everything you can imagine, magnetic fields to surround spaceships, escape systems, flybys of Venus, missions to Pluto. It's all in there. They just didn't have the technology or the budget to pull it all off.
There's a couple more recent ones. I have to point out former chief scientist Jim Green, who was a guest on this program, has an idea for an artificial magnetosphere for Mars.
Yeah.
Now that's interesting. But you're right. Most of those wild ideas that really, really reaching out there, they lie in the 1960s, and that the practicality of things has sort of prevented them, or the cost. But they do serve to show that we can do some really amazing things with space if we have the funding and the ability to do so. Now, with Artemis, though, one question I have about this is that, all right, we have a moon rocket and ostensibly a Mars rocket, but what else can we do? I mean, can we launch a direct probe to the outer solar system with this thing on a fast track? Or if we see another Oumuamua-like object, can we catch up to it with this monster rocket?
Yeah, absolutely. I mean, the Falcon Heavy is a really powerful rocket, but it still doesn't hold a candle to what the Space Launch System is capable of, even in its current configuration, not to mention in that Block 1B configuration that I mentioned. And when they were building it, they actually had a bunch of interesting applications that they might use it for. One, for example, was the Europa Clipper. So they're originally planning to launch the Europa Clipper on an SLS 1B variant. With SLS, obviously, you can start building the lunar gateway and start preparing the hardware that's going to go to Mars. So it's a phenomenally large rocket. And as you said, this idea of Project Lyra, where even today you could chase down Oumuamua and send a lander to go down and analyze this object today. You just need about a 30-year catch-up time for your rocket. But an SLS would be perfect. Even a Falcon Heavy would do the trick. Neither of these are going to be anywhere near as powerful as Starship when and if that rocket platform comes online sometime between now and the end of the universe.
Sometime between now and the end of the universe. And then there's even further with Jeff Bezos.
with the New Glenn, yeah, maybe. Yeah. But I mean, New Glenn is chasing yesterday's ideas. I mean, it's going to have a fully reusable first stage, but it won't be a fully reusable rocket top and bottom stage. Nobody else is working on a fully reusable two-stage rocket, which is envisioned by SpaceX at this point. Although there's actually a bunch of Chinese companies that are working on their own levels of reusability.
That's going to be key, though, because it really does. I think that's the one thing that SpaceX has really demonstrated, is that reusability works.
Oh, yeah. I mean, at this point, we're seeing these rockets land on the drone ships. Many of them have gone beyond 10 flights. Reusability, in the truest sense of the word, is now happening. And when you think about the Falcon Heavy, 3 of its stages are reused. Its fairing is reused. The only part that isn't reused now is the upper stage. It's pretty impressive.
Yeah, and as I recall, there were even some murmurings about figuring out how to reuse upper stages if you can get them back down to the planet.
Yeah, they could never figure it out, and that's why they actually shifted to the Starship concept. I mean, it was just them doing the math, trying to push the math to the point that it would work, and in the end, Starship was actually probably the minimum viable size for a fully reusable two-stage rocket. The math works better the heavier these things get. And Elon Musk has said that, in fact, one that has an 18-meter fairing would work even better than the one with a 9-meter fairing.
That's amazing. Do you think that played into the decision by SpaceX to go with stainless steel, maybe?
Well, I mean, that's a really interesting story because, like everybody, when you're thinking about fully reusable rockets, you go for lightweight material, and the obvious answer is to go with some kind of carbon fiber. And in fact, when NASA was exploring a single stage to orbit aircraft, there was the X-33, which and also the Venture Star. And this was done by Lockheed Martin back in the 90s. And they were building this thing out of composite materials, and they just couldn't get the weight down. And in the end, they canceled the project because they couldn't make a fuel tank that was light enough that could carry the amount of fuel to carry this thing to orbit. And in the end, SpaceX was going down the same pathway, building this carbon fiber vehicle. And at some point, somebody, I'm not sure, maybe it was Musk, said, what if we just made this thing out of steel? which is crazy. But in fact, because steel is so durable, it requires less heat shielding. You can build it outside. It has more tolerances. We know how to work with this material quite well. And then you just have to make the spaceship bigger to compensate.
And it's not a new idea. There have been stainless steel rockets in the past. So this is a material that's sort of tried and true. Even though it might look shiny and unusual, it really isn't in the history of rocketry.
I feel like I have a bunch of old science fiction comic books
exactly
that reveal that this idea was thought of.
Well, I mean, if you look at 1950s science fiction in the pulp magazines, all of the rockets were stainless steel. They were shiny, beautiful, gargantuan things. And what's interesting is that really with like Artemis, it's not. It's orange brown, like a space shuttle, and you can really see the legacy technologies that went into Artemis.
Yeah.
Now, Artemis is also a cooperative effort.
Oh, yeah.
As I recall, it's NASA, ESA, CSA, and JAXA. What is Canada doing as far as, I know we did the Canadarm and all that stuff. What's Canada doing with Artemis?
I don't know. I know what ESA's doing.
Well, Fraser, you paid for it. Yeah, I'm not actually sure what the contributions and efforts are, because I mean, we're all going to go when we go to the moon. It's going to be international consortium, and it's interesting because if you look at the different space agencies of the world, everybody does something slightly different. For example, the Japanese were really out there. They were visiting a comet. They were the first ones, as I recall, and there's just different interesting priorities, whereas NASA, to me, seems to be somewhat conservative. I mean, after all, we've been to the moon, we're going back, and maybe Mars, but it's sort of focused on the moon again, whereas there's a lot of other places out there that we could be going. Do you agree? Do you think that?
Totally not. No, absolutely not. I think you've never been more wrong.
Really? Oh no, I have. Yeah. I have. I've been more wrong.
Well, maybe. I haven't really delved into your catalog enough. But no, I think that the moon is the place. Like, the moon makes obvious sense as the place to go, and it's not just setting boots on the ground, but actually going to stay. It's like the difference between people going and exploring Antarctica and us having a base at the South Pole where various experiments are done in that unique place. And everything that NASA is setting up for the Artemis missions this time around revolves around them going and actually setting up a long-term presence at the moon, which is the thing that should have been done in the first place, although it was expensive. And so it's understandable why they didn't do it. So I want to see a presence on the moon in the same way that we have a presence in the International Space Station, a presence in Antarctica. Eventually we'll have a presence on Mars, and maybe a presence on an asteroid somewhere nearby. So no, it makes absolute sense to do this. And it's the same reason why the Chinese are taking this on as well. Even if NASA doesn't do it, you're going to see a permanently inhabited research station by the Chinese by the early 2030s. No question.
No question on the Chinese. They're after it. And
oh yeah, totally.
Personally, I think that's a good thing ultimately.
Absolutely, yeah.
And not only just for the advancement of the human species, it also gives a political driver for NASA to up its game, and Congress to give them funding, more importantly, and get back into that, because that seems to be the only way we can really get things done proactively, very proactively in space.
Yeah, I mean, I think the things that's really important to understand is that the moon is not has no military value. And so it's not like putting satellites in orbit around Earth and saying, look at this, we can drop a nuclear weapon down on any city we want with 10 minutes notice. The moon is really far away. It's much easier to launch a intercontinental ballistic missile here on Earth than it is to try and launch something from the moon. It is a demonstration of a nation's technological prowess to be able to do that. And so it's
to go there,
and to live there and to stay there and to continue and expand and develop your technology. It is the result of a nation that is investing in science and technology and engineering and is making these things priorities over the long term. And so I think that's what China is trying to show. They're trying to say, hey, take us seriously.
Oh, I think that with the advent of fast, we're taking them very seriously because they are definitely investing in science and technology to a very significant level.
Oh yeah. I mean, they have the largest static radio telescope in the world. They also have they're about to have the largest steerable radio telescope in the world. They're building space telescopes. A bunch of other missions are building their own gravitational wave observatory. So there's a lot going on for sure.
Now, in regards to SpaceX, back to SpaceX and Starship, now this has been delayed, which is to be expected. Never trust Elon Musk's timelines.
Yeah.
You know, always add 6 months or more. But in this case, how far away do you think they are from a launch at this point?
Well, it's very hard to tell, obviously. And I think if you had followed Elon Musk's predictions, they would have done an orbital launch earlier this year or even late last year. But the checklist of items, as we're recording this now in December, the official line from Musk and team is that the next test they're going to do is probably a 20-second test where they fully fill up its oxygen tanks, which is kind of a dangerous step to take, and then run the engines full throttle for about 20 seconds. Then after that, they'll probably do another static test, and then the flight after that will be orbital. And so in the best possible timeline, they run that test next week, they run another test the week after that, and then they go orbital sometime in late December. That seems ambitious to me. I've been saying March. I keep saying March 2023.
I would concur, just based on following it, that it's probably going to slip, but March, about that time.
Yeah. It'll launch when it launches, and I think that there are. I mean, if it was me, like I don't run a rocket company, so I don't. Maybe they know what they're doing, but for me, like the plan is to stack Starship on top of the Super Heavy and to launch the whole thing into orbit. And then the Super Heavy will return and land in the ocean. And then Starship will return and land in the ocean. And then based on that, they're going to try to go to getting them to actually land at the launch facility. But like the Mechzilla, which is the gadget that's designed to pick up and stack up the rockets and catch them because the rockets can't actually land anymore. They don't even have landing legs. They're so lightweight. Instead, they'll land and be captured by this giant crane. But that thing costs a lot of money. And so if they have any accidents, that thing is gone. And it seems really surprising to me that they're not going to be doing more tests. Like we saw a test of Starship. The thing launched, belly flopped, and then landed, and it worked great. Why haven't they been testing this thing out day after day, week after week? Like, let's see more of these. And they will, the first time that the Super Heavy is going to fly, it's when they're going to attempt an orbital flight. Why isn't this thing hopping around? Why aren't they trying to prove that they can really nail the operation of this really powerful rocket before they try to go orbital? So it seems really weird to me, but maybe that's the step that they think is most important because it allows them to test off a whole bunch of components all simultaneously, which never seems like, as an engineer, you want to test variables one at a time very carefully in isolation.
Yeah, but it has to be said too, again, expense. Launching one of these, you might want to take the approach of trying to figure out whatever you possibly can on the ground before you go into launches, and they're very data driven. These rockets, SpaceX rockets, the data collected from sensors and everything is a lot more than normal because they want to try to figure it out on the ground. Plus, let's be honest, Twitter is expensive, so You can't.
Right. Yeah, well, that's the thing.
He's busy.
It's amazing to me. Yeah. Yeah. Doesn't he have better things to do than try to moderate people's conversations on Twitter? That just sounds like the worst job ever.
Yeah, I wouldn't want that job at all. I'd rather talk about space and focus on that.
Yeah.
But then again, I mean, look at us. We made our careers talking about neutron stars.
Yeah. I'm still entertained. Yeah.
I am too. Oh, I've never lost interest. I could actually say that it's increased.
Mm-hmm.
Yeah, I for a long time, as an amateur astronomer like you are, and we drag telescopes out and all that. For a long time, I was sort of not doing that, especially in winter because it's cold. But I've been doing that again lately. I've been dragging out the old Celestron.
That's amazing.
And checking on Mars.
It's funny. Like, I think, and I'm sure you get this too, but when people first show up at my channel, they come in with a head filled with science fiction ideas. They want to talk about wormholes and aliens and black holes and there's in Lagrange points. There's these various
Death stars.
Yeah, all these questions that come out. But after a while, as they gain more knowledge, then the questions become a lot more nuanced. They're interested in the updates to this mission, to that mission, to how this technology works, how that technology works. What is this going to enable of that? Like, you can see this education that's going on, this maturing as people are sort of losing their childlike innocence of science fiction concepts and shifting into the reality of the way space works and the way discoveries are made. And I find it, I don't know, it's kind of, I mean, I always use this sports analogy, but it's like, for a person who really understands the game, understands the players, understands the drama, it's endlessly fascinating to talk about this game, that game, who won this, how things happen over the course of the game. And the same thing goes on as people learn more and more about the actual nature of space exploration and astronomy. The more excited they become at the nuance, at the incremental updates that are happening in this field, and they're less interested in civilizations at the end of time.
Well, I think a good example here would be all sky surveys.
Yeah.
There was a time when somebody first joins your channel, they're like, well, what's an all sky survey? Just point your telescope and take a picture of something. But when you find out what the LSST Vera Rubin Observatory is going to be able to do and how it can detect these interstellar objects like Oumuamua and outer Kuiper Belt objects and all these things that's promised there, it becomes even more interesting in the nuance.
Yeah. Yeah, the example that came out fairly recently to me was there was this survey where astronomers had gone through every single Type 1a supernova that had ever been discovered, and since 1998, and they put them all. They sort of normalized all the data and double checked all the observations and put it in this great big grid, and then they used this to make predictions about or measurements of the universe at different ages, and they were able to confirm estimates of dark matter with ever narrowing error bars, etc. And it was excruciating work, like some astronomical observations of all humanity over the last 30 years to build this list of 1,700 Type 1a supernova. Vera Rubin will do 1 million. It'll find 1 million of these. Like, it's bonkers how powerful this. But and the other one, of course, is Gaia. Like, I just keep going back to the Gaia well. Every time there's some new discovery, it's often made with Gaia, thanks to Gaia. The closest black hole ever seen, the lightest neutron star, brown dwarf orbiting another star, and so on. It all just comes back to Gaia. They've mapped out the shape of the Milky Way with precision. It's amazing.
Yeah,
I love surveys.
Oh, me too. I'm very much and time surveys like Kepler. And with I can't even remember the name of the mission now that we have that replaced Kepler. Totally slipping my mind.
Like a plane, like TESS? You think like a planet hunter?
Yeah, it's TESS. It's TESS.
Okay,
it's TESS. I just couldn't for some reason remember that. That's called turning 47.
Yeah. Oh,
man,
so young.
Well, not for long. Now, Fraser, if you had to look back in the year in review, with DAART, James Webb, launch of Artemis and all that, what was the one that excited you the most? What was the development in space or in China? What was the development in space that excited you the most?
Well, absolutely JWST. I mean, no question. I mean, we talked about Artemis, and I'm excited about what the future that Artemis holds. I mean, obviously, this first mission is uncrewed. Maybe the next one is going to have some people to recreate the Apollo 8 mission. It's going to be Artemis 3 when humans go and they get into they fly out to the moon and they get into a Starship and they land on the surface of the moon and they get out. Like, that's going to be great. But no question, this year, the most exciting story has been JWST with its picture-perfect launch back at Christmas last year. I mean, we're almost a year since it launched.
Almost a year.
Yeah, but then the release of the first science images back in July, and then there's just been this nonstop release of new papers and data and pictures. And I've been on it maybe more than most people have, and so a lot of people are like, I haven't heard much from JWST, and I'm like, I've been reporting 2 stories a week in my space news segment. It's been amazing, and we're not even at the good stuff yet. The researchers, when they book time on JWST, they get a 1 year of proprietary access to the data that they have requested until they have a year to write their paper.
Just wait.
And we've only seen a couple of papers. So the only paper that I know of specifically that came up from that JWST data, actually there's been a second one now that I've seen, but I'm sure there's been more. But one was the characterization of the atmospheric data around the exoplanet, and where they saw sulfur dioxide chemistry, water in the atmosphere, carbon dioxide, carbon monoxide, sodium, potassium. It was amazing. Clouds. And there was one that just came out today where they mapped out the interstellar light, the light from the stars that aren't attached to galaxies, intra-cluster light. And they were able to make a map of dark matter using this light. But they just keep coming. And so the pictures are amazing, the snippets that we get, but as you said, just you wait for the papers where the scientists have had a full year to digest and compare and double check and get peer review, and then the discoveries are going to come fast and furious.
The avalanche is coming. Mm-hmm. Now, I think, though, the one thing about JWST that blows my mind specifically is getting that deployment to go exactly perfectly as it did, with so many potential failure points, and it made it past all of them.
Yeah.
And that really tells you that nothing like this would have been attempted in the 1980s or 90s, nothing this complex. Yet now we do it, and it's only going to get better from here. Do you envision any of the planned missions or suggested missions in NASA actually being even more complex to launch and deploy than JWST?
No. I think that JWST itself was a wake-up call to dial back the complexity of the mission. So, originally, JWST was going to be called the Next Generation Telescope, the NGT. And it was originally, there was a meeting in 1998 to discuss this, that's when they started to hash out the ideas, and they expected that the budget was going to be about $1 billion, and that they would probably have this thing built and launched sometime by 2010. Then the budget went up to $4 billion, then the budget went up to $7 billion. In the end, it was $10 billion, and the vast majority of the expense was actually trying to reduce the weight. They had to figure out how to remove every piece of weight off of this spacecraft, every screw, every joint, everything. And that just made everything so much more complicated and so much more expensive. And NASA had been originally considering building a much larger follow-on telescope for JWST. They were calling it LUVOIR, the Large Ultraviolet Infrared Observatory. It was going to be somewhere in the 12 to maybe even 20 meter range as a telescope. So that would be bigger than the biggest telescope that currently exists on Earth, but in space. And it would be a true successor to the Hubble Space Telescope. So it would view in the same wavelengths that Hubble does, not in the far infrared like JWST does, but it would see invisible and infrared. And it would just be able to produce some astonishing images. But based on what happened with JWST in the most recent decadal survey that came out just last year, they scaled the whole idea back down. And so now LUVOIR will probably be a a telescope that is the exact same size as a JWST. So it's going to be like 6.2 meters, 6.5 meters, but be infrared, visible, and ultraviolet like Hubble, and which will actually make it a lot simpler. So I actually think we're going to see simpler telescopes building on the knowledge and expertise that was gained with this mission. If Starship works and works well, then I think we will see some other really interesting ideas, because then weight is no longer an issue. You can launch a 10-ton space telescope, a 20-ton space telescope, and so you don't have to worry about the weight. And you've got a fairing that is almost twice as big, so you could just take the Keck Observatory, stick it inside the Starship, and just launch it off to space. Almost, not quite. So I think we're going to see some simpler versions. So no, I think we won't see more complicated. We're going to see simpler. It was between Artemis and JWST, those were both kind of embarrassing, long duration, budget gobblers mistakes. Yeah. There's a lot of. We're all excited about JWST, but then there's a lot of wonderful, exciting ideas have fallen to the wayside because of all of that budget.
Well, that brings up the opposite side of it. We're actually moving into a period of potential private exploration of space using private probes that can go and do science much cheaper and much more efficiently than a government can. Mm-hmm. And that's something that, for example, a life finder at Venus is on the table, and questions like that to see what is that, if there is indeed abnormal phosphine levels there, what is it? And the idea is, don't go to government, just get a privately funded donation-based spacecraft and go look. So that's another wild card, is that there are that thinking it's becoming possible to do things like crowdfunding space exploration with very, very simple CubeSat probes. Nothing special, just answer the question. Do you think that's going to be a thing? Do you think that we're going to just sort of be blindsided by missions that are sent not by governments but by private entities?
No, I don't think so at all. The Life Finder is great, but in many cases that is being partly covered by Rocket Lab. They're going to be covering the cost of launching this mission. You've got some other benevolent donators that are going to be helping to create this mission, but no, I don't think so at all. It's just so expensive, and there is no return on investment. There's no return on investment on a space telescope that is designed to search for the first signals in the universe. And it's not like you can advertise on it and stuff. And so because there's no business model, it's going to be the realm of universities and government organizations. I think where you're going to see the privatization is what happened with access to space, because there is a business model there. You saw with NASA now, NASA doesn't have a way to fly astronauts to the International Space Station. I guess theoretically they could fly an SLS, but they really don't. So instead, they pay per seat to Boeing and SpaceX to send astronauts up to the International Space Station. They know exactly what the price is that they're going to pay. That company is incentivized to build a spacecraft and make a profit, but also use that same spacecraft for tourist flights and other ideas that they may want to have. And that works really well. You don't see NASA designing a car or an airplane to carry the astronauts from center to center. They fly commercial. In some cases, they fly on private fighter jets, but still. So no, I don't think so. I think that model falls apart, and I think I would much prefer. I wish NASA would get out of the rocket building game entirely. They should be putting their energy into the places where there is no business model, or the places where the risks are just too great, the unknowns are too large, and it makes sense, where you need someone to de-risk this problem. Innovative propulsion systems, new materials. I think NASA's job is to say, here's this clever idea for a propulsion system, a nuclear propulsion system, an ion engine, whatever, and we will investigate this to figure out if it's feasible. We will develop a prototype so that other people can work with it, and then we'll get out of the way again and let commercial providers take over and build it and integrate it, and then NASA will buy them when they need to launch a rocket that does that. So I think, as wonderful as Artemis is, I would fundamentally disagree at the underlying strategy of how they built it. It's, I think it's a model that is overdue for replacement.
I think the case could be made that Artemis is a rocket 25 years too late. It's what we should have been developing in the 1990s or even the late 80s, as opposed to today. And now with the possibility of Starship hanging around, I don't know how many Artemis launches we'll actually see.
Yeah, I mean, as we said earlier, right, that you've got Elon Musk time. You don't want to place all of your eggs in the Elon Musk basket. And so what are you going to do? Are you going to say, well, you know what, we're going to not continue forward with these moon exploration plans until Elon Musk delivers us a safe rocket that does what we need? But I think that they could have chipped away at the problem and come up with a solution that was vastly less expensive. One idea that I've heard that's kind of cool is you could build, say, a Falcon Heavy rocket, and then you put a United Launch Alliance upper stage on top of it that's very powerful, and then you could launch an Orion capsule on top of that, and it would cost you $1 billion as opposed to $4 billion, and there would be almost no development cost because you're just off the shelf. SpaceX had been considering building a deep space version of the Crew Dragon, which is what carries astronauts. The Crew Dragon is actually quite large. It's like twice as large as an Apollo capsule. And so theoretically they could have upgraded it and it could have done work in deep space. It's no Orion, but it still could have taken people to the moon and back. So I think there were a lot of paths they could have gone, but it's a momentum thing. It's a jobs program. You're taking the entire workforce of the Apollo missions was shifted into the space shuttle, and then they were shifted into the SLS. And because you have people who work in every state in the US, you've got this enormous political pressure not to go and lay off hundreds of thousands of people. You keep them working.
Yeah. Now that actually brings up an interesting sideline, is that ULA with the coming Vulcan rocket. I know you recently talked to Tory Bruno, and so did I.
Mm-hmm.
And I'm actually very excited about that. High energy launches from relatively economical rocket, as far as I can tell. What's your view on the Vulcan Centaur system?
Well, I think as an upgrade, so for people who don't know, the Vulcan Centaur, I mean, the Centaur is the standard upper stage by United Launch Alliance. It's the one that carries a lot of their spacecraft to geostationary orbit, etc. The difference is the Vulcan. And so traditionally they've got the Deltas and the Atlases, and they're replacing them with this new rocket. It has Blue Origin built BE4 engines. B3? B4? Anyways, Blue Origin engines, which are designed to be reused. And so the current plan is that the rocket will fly to space. It will ditch its engines. They will return via parachute, or maybe even this inflatable cone that we saw tested just a couple of weeks ago. And then they'll recover the engines and then build a new rocket around them. It's a good step. And in the words of Tory Bruno, I mean, you are reusing the most expensive part of the rocket, which are the engines. The fuel tank is not that expensive. But I think, you watch SpaceX Falcon 9s take off and land, and all they do is they give them a quick refueling. It's hard to argue that they haven't nailed the paradigm here.
They don't even wash them.
Yeah. Why wash them? Yeah. The soot just makes them go faster. And so I think it's, when I talked to Tory Bruno, I asked him a very similar question. It was like, how do you justify building a partly disposable rocket in an era when SpaceX has demonstrated this? And his response is precision, that what a very powerful, mostly disposable rocket is going to get you is you're going to get the ability to make sure that your rocket goes exactly where you want it, that you've got fuel to spare. And if that's what's important to you, then that's what you're going to get. And that argument doesn't really fly with me, like if Starship actually does function and they're able to launch these rockets for 1/10 the price with 10 times the mass, it's really hard to argue that it makes more sense to go with the partly reusable Vulcan rocket, which still doesn't even exist. I mean, they've taken a couple of the Blue Origin engines, but they haven't even been able to integrate them into a rocket and do a test flight yet. They've tested them in their test beds, but they haven't gone the full length with these things. So, when we're recording this is kind of a funny time because we don't know if Starship is going to work. It's possible that the whole thing will fail. That it was doomed from the beginning and nobody ever knew why. And it's when they finally attempt to launch these things, they'll spend 10 years not making it work. That's possible. I don't think that's the likely outcome, but I think it's possible. I mean, we've seen Starship. We know that they can nail reusable rocket boosters. We assume they've done the math. This would be a very expensive failure if they just kept doing this. But how do you not take that into account running a company in this day and age and say to yourself, I'm not going to develop a fully reusable two-stage rocket. They must have them on the drawing board. And if they have them on the drawing board, then they're ceding the victory already. They're playing catch up to SpaceX. It seems madness to me if that's not the case. So I don't get it. I mean, I don't think people realize, like, if Starship does fly, it will gobble up the entire launch market in a matter of months and then just run away with the whole thing.
What do you think about the originally envisioned potential of Starship being a point-to-point, Earth point-to-point landing? In other words, go to Australia in half an hour. Do you think that has legs, that aspect of it?
No.
I don't think so.
That's crazy. Yeah, that's madness. Imagine the flight, right? You and Grandma, you're going to take a trip to Australia, and you go out to the launch facility, and you take an hour to get ready, and you go through whatever training is required to handle the flight. The thing takes off, flies up to orbit, belly flops through, just imagine, however people are sitting, you are falling, belly flopping through the atmosphere, and then at the last second, this thing flips over and fires its retro rockets to land. Everybody's going to be vomiting in the cabin, and you've saved yourself. I mean, yeah, the flight part only took an hour, say, but you have, if you wanted to fly to Australia, it would have taken you 15 hours. For most people, I think getting to Australia, it's not about the time you spend on an airplane, it's the expense. And there's no way that a rocket won't be cheap. It's going to be cheaper than flying in an airplane. So no, I think that I ended the noise, and no, it seems like madness to me personally.
The only in I can see, and I see the same problems you do. I mean, look, it's really easy to just hop on a flight and go to Denver, something like that. It's really easy to do. But jumping on a rocket to go to Australia now, however many hour, almost day spent on a plane is better, because most people don't get sick. Some people do. But the one thing that I might be able to see where this could work is certain types of cargo. If you need to move something from, Japan to South Africa or something like that, and you have a whole lot of it and it justifies it, and this cargo needs to get there as quickly as possible, say humanitarian relief or something like that.
Well, military probably.
Or military or something like that. I could see maybe an in there, but I don't really see it being very frequent.
No, it doesn't feel like you're going to replace intercontinental airplane flight with this.
Yeah, I don't think the airlines are worried.
No.
They're worried about other things.
Yeah.
But the reality is that I don't think that could materialize. Now, space tourism is a completely different story. If you really want to go to space and you want to go and feel weightlessness and pull a William Shatner, Starship seems like the one that's going to be the most capable for that. I mean, you could basically fly a rudimentary hotel in one mission up there with this thing. So that I think is going to provide some market. But my question for you is this: do you think it's a novelty? Do you think that after 10 years, people are still going to want to go and be in space? And, will it be like a Mount Everest where people still do it? Or do you think it'll just sort of flatten off at some point and become old hat?
Yeah, there's a company, like what I think people want is they want that view. They want to get that overview effect of seeing planet Earth from a great height. There's this company called, is it Space Perspectives? They're building an orbital or like a high altitude balloon platform. So you'll get on this balloon gondola, you'll fly up to the edge of space, and then you'll spend several hours up there before descending again. You will see the curvature of the Earth, but there'll be a bathroom and you'll be still experiencing gravity, and you can sit and have a drink and look out the window and go, wow, I can see my home house from here. That seems vastly more civilized than all of the downsides of flying into orbit. I think I would, if I was offered a free flight and I was guaranteed that it was safe, I would go to orbit for sure. I would give that a shot. So I would love to go to the moon. That would be amazing. And so, no, I think there will always be a place, and maybe Starship is going to be the thing that's going to bring the cost down. But I'm not sure how much of the world launch market that's going to be able to satisfy.
I think it's going to be mainly a Mount Everest thing. Going to a Mars colony or going to LEO. I think it's going to be for people that want to get married in space, do something novel, or they're adventurers, like the people that climb Everest or climb mountains and things like that. There'll be that niche market. But most of us, myself included, I want to stay here. I don't want to go into space.
Yeah, totally.
I babble about space, but I don't want to leave here. So first YouTuber in space, that would be tempting, but no.
Well, let Scott Manley do it.
My view on it is that we'll let Scott Manley do it. Actually, that should be the solution to all our problems.
Yeah, just let Scott Manley go first.
Ask Scott Manley. Yep. So I think that there will be a market for it, but I think it's going to be a niche market, and it always will be. As much as I would love to realize the ideas of Gerard K. O'Neill and have people living in space, and permanently people born on O'Neill cylinders, things like that. As much as I would like that, the reality of it isn't very good. Reproducing in that environment and all that sort of thing, just harder than it sounds.
Yeah, well, I feel like that kind of thing is more a factor of a future when our infrastructure is so good in space that those kinds of applications become easy to do, right? Like if you want to go and live in Phoenix, it's possible. It's harder than living somewhere else, but now we have electricity grid, we have a water grid, you have roads, you have air conditioning systems, you have refrigeration. And so all of these technologies have made living in this place that's actually quite difficult. That isn't very sustainable for human habitation at that kind of level, suddenly becomes on the table now. And now you have however many million people live in Phoenix just because the place technology is supporting our existence there. And I think that you kind of have to look at humanity's future in space on the same way. We're going to have space stations. We're going to have a permanently inhabited research base on the moon, maybe something on Mars as well. But I don't think that we're going to have people living in any of these places until our technology trivializes it. But the trivialization of it does feel inevitable. So it won't be 30 years the way everybody is hoping, but it might be 300 years because technology just marches on. And eventually you've got infrastructure in space. You've got regular refueling going to these various places. You've got the ability to build giant 3D structures and rotating 3D structures in space. And after a while, actually living in the O'Neill cylinder is starting to make a ton of sense. Property there is cheap compared to living on Earth or whatever. So it's all just a factor of time. And when you think about how quickly we might actually build a Dyson sphere, like if you just consider the rapidly growing rate, the exponential nature of human technology and power use, things that seem impossible are actually, you can almost put them on the calendar for when we will have accomplished these things. And it's not that far. Just year after year of exponential growth has a way of taking over an entire galaxy.
Fraser, you have just named my O'Neill cylinder. Whenever I found an O'Neill cylinder with my subscribers, it's going to be called Space Arizona.
Space Arizona. Perfect. Yeah.
Yes, with the capital being Space Phoenix. All right, we have to take a break. When we come back, we'll talk about alien life with Fraser Cain of Universe Today. Event Horizon and my channel are now available as a podcast on Apple Podcasts, Spotify, and YouTube memberships. Early ad-free episodes, bonus episodes, and sleep-focused content. Sign up now by clicking the links below to your platform of choice.
John, have you seen my context chip?
No, what makes you think I have it?
Have what, John?
The context chip.
Oh, yes. I don't know where that is.
Well, I saw you-know-who in here yesterday. The possum might know where it is.
I would hope so. He'd get lost a lot otherwise.
Wait a minute. No, the chip, not the possum.
Speaking of chips, John, have you seen my context chip?